Welcome to the course. Have you ever looked at a spreadsheet full of numbers and thought, what am I supposed to do with this? If so, you're in the right place. Data is everywhere, on your phone, in your bank account, and behind every recommendation you get online. But having access to data is not enough. You need the tools to make sense of it. That's where Databricks comes in. This course is your beginner-friendly path to understanding how Databricks works and how you can use it even with zero prior experience. We'll walk through real examples, learn actual datasets, and show you how professionals clean, explore, and visualize information that drives real decisions in business, research, and technology. Whether you're curious about a career in data or simply want to add a practical skill to your toolkit, this course is built to support you step by step, from scratch. Let's start with a simple question. Why Databricks? Why now? Think of Databricks as a digital notebook where you can work with data, run code, visualize results, and even collaborate with others. It brings together tools used by data scientists, analysts, and engineers, but without the complicated setup that often gets in the way of learning. Here's what makes Databricks so useful for beginners. It runs in your browser. No installation, no downloads. You can write code and see results instantly. It works with real data, the kind used in business and research. It's free to start with Community Edition account, which we'll set up later. But this course is not just about choosing a tool. It's about building skills you can take with you. You will learn how to learn and clean data, create visualizations that make sense, use simple code to do powerful things. And the best part, you don't need to be a programmer or math expert to follow along. What to expect from this course? We have divided the course into 5 clear modules, each with short, focused lectures. You will work on mini activities, get your hands on real datasets, and build up to a small final project that pulls everything together. It's all designed to build your confidence, not just your knowledge. Here's what our approach will look like. We will explain concepts in plain language first, then show them in action. You'll watch me walk through examples, and then you will try them on your own. Each module includes short reflections or assignments to apply what you have learned. You'll finish the course with a portfolio-ready notebook that shows your skills. A quick real-world example. To show you how relevant this is, let me share this. In 2023, Starbucks used Databricks to analyze customer behavior across multiple countries. The data team cleaned and organized millions of transactions to identify patterns, such as the time of the day when people prefer cold drinks versus hot drinks. They leveraged this insight to refine their store promotions and increase sales. That's not theory, it's real data, used in real time with tools like the ones you will be using here. Let's talk about you. Throughout this course, I'll remind you that your background, whether you're a business major or computer science student, or simply curious, matters. You don't have to become a data scientist overnight. You just need to know how to ask good questions, learn data, and present what you find. Before we wrap up, the only thing you need to bring is a willingness to learn through hands-on experience. This is not about memorizing commands. It's about getting comfortable with data and technology and maybe even having a little fun along the way. What is Databricks? Have you ever worked with a huge dataset and thought, this would be easier if I didn't have to switch between 5 different tools? That's the exact problem Databricks set out to solve. What exactly is Databricks? At its core, Databricks is a cloud-based platform that helps you work with data in one place. It combines the best features of several tools. A notebook interface for writing and running code, like Jupyter Notebooks. A data warehouse for storing and accessing large datasets. The power of Apache Spark lets you process data faster than traditional tools. And an environment for collaboration, allowing teams to work together in real time. But the beauty of Databricks is that you don't have to know all of that to start using it. If you have ever written a sentence in Google Docs, you already understand part of the experience. It's interactive, online, and designed to make teamwork easier. So, is it just for experts? Not at all. In fact, Databricks Community Edition was explicitly built for learners like you. It runs in your browser and provides access to all the basic tools without requiring any installation. You can write simple commands, load in a dataset, and watch your code run without having to configure a single server or set up any complex software. Think of it this way. Databricks enables you to transition from I want to analyze this data to actually doing it without having to jump through hoops. Why is it so popular? There are 3 main reasons companies love Databricks. Speed. Traditional tools can take hours to process large amounts of data. Databricks can do it much faster using Spark under the hood. Scale. It can handle massive datasets from gigabytes to petabytes But don't worry, we'll start small. Simplicity. Instead of using one tool for coding, another for visualization, and another for storage, Databricks put it all in one place. Let's take a real example. Viacom CBS, a global media company, used Databricks to analyze streaming data from its digital platforms. They were able to identify the types of shows people watched during different times of the day, and even spot trends by region. By centralizing all their data analysis in Databricks, they reduced their time to insight by 60%. That's not just convenient, it's game-changing. How does Databricks help beginners? Here's what makes it especially good for students. You can start small and grow as you learn. It's cloud-based, so there is no need for downloads or expensive hardware. It works with Python and SQL, two of the most accessible languages in data science. It teaches you real-world workflows, not just classroom theory. Instead of learning how to use 10 separate tools, Databricks helps you focus on how to think with data. And that's the most valuable skill of all. You have just learned that Databricks is not just another tech platform. It's a practical, accessible way to work with real data. What makes it powerful is not just the technology behind it, but the way it brings everything together. Code, data, and collaboration all in one place. And the best part? You don't have to be a developer or data scientist to start using it. You just have to be willing to explore, test things out, and learn by doing. Real-world uses of Databricks. Have you ever wondered what companies actually do with all the data they collect? They're not just storing it, they're using it to make decisions, improve products, and understand human behavior. Why are real-world examples important? When we study a tool like Databricks, it's easy to focus on the how. But to stay motivated, we also need to understand the why. Seeing how companies use Databricks in practice helps you visualize its potential, discover new industries that use data, connect your learning to real challenges. Let's learn 3 credible case studies that show Databricks in action. Healthcare. Regeneron accelerates COVID-19 research. During the early stages of the COVID-19 pandemic, the biotech company Regeneron was working with massive genomic datasets to better understand the virus and immune responses. With Databricks, Regeneron was able to process over 1 million patient records in record time using collaborative notebooks and scalable Spark clusters. Instead of waiting days to analyze patient trends, researchers were able to run models, get insights, and adopt clinical trials faster than before. The result? Accelerated treatment development and smarter research, all made possible through Databricks. Takeaway: in healthcare, Databricks speeds up research that saves lives. Retail. H&M personalizes shopping at scale. H&M, one of the largest fashion retailers in the world, uses Databricks to personalize recommendations and manage inventory across thousands of stores. The company tracks data from customer purchases, online behavior, and local demand. Using Databricks, they clean the data daily, analyze trends, and generate dynamic pricing and restocking decisions within a single environment. By integrating both machine learning and business logic into a single platform, H&M produces overstocking and enhances customer satisfaction through more informed recommendations. Takeaway: in retail, Databricks helps deliver the right product to the right customer at the right time. Media and entertainment. Viacom CBS reduces time to insight. In the media space, Viacom CBS uses Databricks to analyze content engagement. With viewers consuming media across various apps, streaming platforms, and cable, the company collects millions of rows of data daily. Before Databricks, reports could take days to generate. After switching, Viacom reduces its time to insight by over 60%, helping their teams to respond faster to what audiences love or skip. They now use predictive analytics to decide where to place ads, which content to promote, and even what new shows to greenlight. Takeaway: in entertainment, Databricks powers faster, smarter decision-making in a fast-moving industry. What these use cases have in common? Across these examples, there is a clear pattern. Databricks supports collaboration, allowing multiple teams to work together. It handles large-scale data, from patient records to retail behavior. It shortens the time between collecting data and actually using it to make a decision. Whether it's speeding up drug trials, optimizing store shelves, or shaping what you watch on Netflix, Databricks is quietly working behind the scenes. How does this relate to you? Even as a student, you can learn the same skills used in these settings. The version of Databricks we are using, Community Edition, is simplified, but the structure is the same. When you write code, analyze a dataset, or create a graph, you are doing what real data teams do every day. It's not about knowing everything upfront. It's about understanding how data helps solve problems and getting comfortable with the tools that make that possible. As you have seen today, Databricks is not just a classroom tool. It's solving some of the world's biggest data problems, from vaccine development to predicting your next favorite movie. The goal is not to become an expert overnight, but to understand how data shapes the decisions around us and how you can be the part of that process. Navigating the interface. Have you ever opened a new app and felt completely lost? Like you didn't know where to click or what to do first? We have all been there, and today we're going to make sure that doesn't happen to you with Databricks. First of all, we'll sign up for Databricks. For that, you will just write in here as Databricks. Scroll down a bit, click in here, and click on Try Databricks. And you will just have to sign up using this one and continue with Google if you have already logged into Google account. And you will just have to write the name. For example, we'll just go with click in here, click on continue. The dashboard, your home base. When you first log into Databricks, you land on the Workspace dashboard. Think of this as your home page. From here, you can access your folders, notebooks, and shared content. Key areas, home or workspace. This is where all your personal files live, your notebooks, folders, and results. Share workspace. If you are part of a team or class, this is where collaborative files can be accessed. Repos, optional, used in professional settings for version control, but you can ignore this for now. Notebooks, where the magic happens. Notebooks are where you will do most of your work. You can write code, add text, visualize data, and more all in one place. To access Notebook, you can just click in here, New, and go to Notebook. Click in here. Each notebook is made up of cells, code cells for running commands, text cells for adding instructions, titles, or notes. This is the area where you can write code or write commands. For example, you just write in here as 2 plus 3 and click in here to run this one. And here you can see this gives us the results as 5, as 2 plus 3 is 5. You don't need to memorize commands. You can write code, run it, and make changes in real time. Databricks is interactive by design. Clusters, the engine behind the scenes. Before your code can run, you need a cluster. Think of it like a power source. A cluster connects your notebook to a computing environment that can actually execute your code. In the Community Edition, you can use a small, pre-configured cluster. It takes a few minutes to start, but once it's ready, you can run all your notebooks. Analogy: if your notebook is a car, the cluster is the engine. No engine means no movement. Tables and data files, where your data lives. Next, you will want to work with some data. Databricks gives you access to built-in sample datasets, but you can also upload your own. To view datasets, you can just click in here as dashboards. And for example, if you want to go with create new dashboard and click on data, add data source and click in here as all, click on samples. And for example, you just want to go with this database, you can click in here. And for now, you can just click in here as sales transactions and click on confirm. Here you can see you have a sample data that you can work on as transaction ID, customer ID, franchise ID, date and time, product, quantity, unit price, total price, payment method, and card number as well. So you can just work on it if you don't want to upload your own data for now. Preview the data before using it in a notebook. Search and navigation tips. Here are a few helpful shortcuts. Use the search bar to find notebooks quickly. And this is here where you can search for data, notebooks, recents, and more. Click the recent tab to return to past files. For example, when you just click in here as recents, And here you can see you have worked on a notebook, dashboard, and another dashboard as well. Organize notebooks in folders to stay tidy. You don't need to memorize everything today. Just learn and explore. You'll find that it's similar to navigating Google Drive or any other cloud workspace. How this ties to real work. At companies like Comcast and HSBC, teams use shared Databricks workspaces to write code, analyze data, and collaborate across departments. Having a clear folder structure and naming system keeps everything organized when hundreds of people are involved. In your case, good organization from the start helps you focus on learning rather than searching for files. You have now taken the first real step into using Databricks. It might have felt like clicking around a new tool, but in reality, you have already done something bigger. You have learned how to navigate a professional-grade platform used by some of the world's top organizations. Workspaces, notebooks, and clusters explained. Have you ever opened a new tool and wondered, okay, but how does this all fit together? Workspaces, your filing cabinet. Let's start with a workspace. Think of this as your personal filing system. Inside the workspace, you will find folders, notebooks, and sometimes shared documents. To access workspace, you can just click in here. Here you can see, you can just click in here. You have all these dashboards and work that you have created, dashboard, notebook, and Genie space as well. Everything you create in Databricks, from a quick data experiment to a full analysis report, lives inside your workspace. Here you can create folders to stay organized, for example projects, practice, or assignments. Move notebooks between folders as your work grows. Share folders with classmates or team members if you're working together. Real example. In corporate settings, such as at HSBC, teams organize their workspace by project, assigning folders to categories like fraud detection, risk models, or client segments. This helps keep massive data efforts focused and collaborative. Notebooks, where you work with data. Now let's talk about notebooks. These are your main working documents in Databricks. They combine text, code, and output, all in one place. That means you can write explanations, add code, run it, and see the results instantly. To access notebooks, you can just click in here as new and click in here as notebook. So you will have this interface. Key features: text cells for instructions, titles, or notes written in Markdown. Code cells for writing Python or SQL code and running commands. Output displayed right below the code cell, allowing you to instantly check your work. Why notebooks matter? They make your work easy to follow and replicate. Whether you're cleaning a dataset, creating a visualization, or doing basic math, you will do it in a notebook. Real example. At Yelp, data scientists use Databricks notebooks to test algorithms that suggest restaurants. A single notebook can show the input data, the testing code, the model output, and a summary written for non-technical teams, all in one document. Clusters, the power behind the scenes. Finally, let's look at clusters. A cluster is what runs your code. It's a virtual machine, a temporary computer in the cloud that does the heavy lifting when you hit run in your notebook. In Databricks Community Edition, you get access to a free, simple cluster with limited resources. But it's enough for everything we'll do in this course. To create a cluster, you will just click in here as compute and click on create SQL warehouse. And here you can see you will just name it in here as, for example, demo cluster, and you can just set it to minimum 1 and maximum 2, for example, and click on create, or you can just click in here as advanced options, and we'll just skip it for now, and you can just click in here. You can add people in it as well, but for now we'll just skipping it, cross this one. And here you can see you have created a cluster in here, which is in running condition. How it works: you create a cluster usually just once, attach it to your notebook, and start it before running the code. It may take a minute or two to complete. Analogy: if your notebook is the car, the cluster is the engine. Without it, the notebook won't go anywhere. Real example. At Shell, clusters are used to analyze streaming sensor data from oil rigs. Because the data is huge and changes constantly, the clusters must be powerful and always running. However, the workflow of running code in a notebook using a cluster remains the same at its core. How they all work together. Let's say you're working on a small data project. Here's what the flow looks like. You organize your files in a workspace folder. You create a notebook inside that folder. You start your cluster and connect it to the notebook. You write code, run it, and view results all without leaving the notebook. This is how analysts, engineers, and students alike move through real data workflows using Databricks. Workspaces, notebooks, and clusters may seem like separate pieces, but together they form the foundation of every data workflow inside Databricks. Understanding how they connect is what turns Databricks from a tool into a workspace that's truly yours. Creating your first notebook. Have you ever had an idea but didn't know where to start writing it down? Creating your first notebook in Databricks is kind of like opening a blank Google Doc or Word file. But instead of just writing text, you can run code, see data, and build something interactive. Today we'll walk through that first step, how to create a notebook and actually use it. Step 1. Create a new notebook. Once you're logged into Databricks, creating a notebook is simple. You will just have to click in here as new and click on notebook. So this interface will be opened and you can just rename it in here. You can just click in here, rename it as first notebook, press enter. So if you want to move it into a new folder, you can just click in here as file, click on move, create a new folder, and for example name it as Databricks course and click on create and click in here to move it. So first notebook moved to this specific folder. You have to choose a default language. Python is a safe starting point, and here you can see you have selected Python in here. You also need to attach it to a cluster, just like the cluster you created earlier. To connect to a cluster, you can just click in here as connect and click on serverless. It is connecting. It might take 30 seconds to 1 minute, and here you can see it has been connected. Step 2. Understanding notebook cells. Notebooks in Databricks are made up of cells. You can think of each one like a block or step in your workflow. There are two main types. Code cells, where you write and run code, Python or SQL. Text cells, Markdown, where you write notes, titles, instructions, or comments. Let's start with a simple code example. In a code cell, you will just write in here. For example, you just want to add two numbers and write 2 plus 2 and click run or press shift plus enter. You can click on run in here, or you can press Ctrl plus enter to run this command. You can just click in here. You should see the output as 4. Here you can see. That's it. You have just run first command in Databricks. Now try a text cell. For that you can just hover over in here, and here you can see you can add a code cell or a text cell as well. For text cell you can just click in here. For example, you just write in here as this is where I start exploring data and click enter and just click on outside this cell, and here you can see this is a text you just wrote in here. You can format text using Markdown, headers, bullet points, bold, etc. It's helpful for keeping your work readable, especially when you come back to it later. Step 3. Good notebook habits. A clean notebook is a usable notebook. Here are a few habits that professionals follow. Use titles and section headers to break up your notebook. Comment your code to explain what it does. Run cells often so you can catch mistakes early. Name notebooks clearly. Avoid names like Untitled 12. Real example. At companies like Zillow, data analysts use Databricks notebooks to test pricing models. The notebooks are formatted like stories with explanation at the top, data exploration in the middle, and conclusions at the end. That clarity allows their work to be reviewed by both engineers and business leaders. Step 4. Saving and reopening. Databricks autosaves your work, so you don't have to worry about losing progress. To revisit your notebook, go to Workspace. For example, you can just click in here, and here you can see you can just open the folder that you have created, and you can just open the notebook that you have just created. And this is the data. Your notebook will open just as you left it. You can also export notebooks as PDFs or source code to share with instructors or collaborators. Starting your first notebook may feel insignificant, but it's a significant milestone. You have just created your own space to work, test, and build something from scratch. That's the foundation of every data project, from simple summaries to complex models. Remember, notebooks grow with you. What you start as a few math problems today could become a case study or analysis down the road. Importing a dataset. Have you ever stared at an empty notebook and thought, okay, now where's the data? What is a dataset? Before we jump into Databricks, let's quickly define a dataset. A dataset is simply a structured collection of data, usually organized into rows and columns, like a spreadsheet. It might be about anything: customers, sales, weather, sports, or even your Spotify history. Databricks can work with many types of datasets, but the most common formats you will encounter as a beginner are CSV files, comma-separated values, tables already available inside Databricks, JSON or Excel files, less common for first projects. Option 1. Using built-in sample datasets. The easiest way to start is by using Databricks built-in sample datasets. These are already loaded into the platform, you just need to call them. For that, you will just click in here as File and click in here as Add Data. And you will have all these options available, like when you click in here to see all and scroll down a bit, and here are all the data available that you can use as a sample. As you have like Google Ads, Google Ad Manager, and Google Sheets as well. But if you want to upload your own, you can just click in here. Or you can just go to dashboards in here, click in here, and create a new dashboard. Here you can just click in here to add data, and click in here to add a data source. You can just click in here, click on all, and you can use any of these. For example, samples, you can just click in here, and you can use any of these, for example, AccuWeather or Health Variety as well, or Information Schema, and you can use any of these. For example, you just want to go with this one, and trips as well. Click on confirm. It might take 1 or 2 minutes. So here you can see you have all this data available. You can just scroll down to see all the data is loaded correctly, and you can just review it. And now we'll just go back to Workspace and go to our notebook. So you can use this data to visualize anything that you want to, or you can test anything that you want to do in Databricks. For example, you can just click in here as untitled page, and you can just click in here to visualize this one. And for example, you can click in here, and now here you can see when you just click in here, and you have dataset as trips. So you can use bars or anything you want to show. For example, you just want to go with area, and you have to select x-axis and y-axis. You can just click in here, and for example, you just want to go with fair amount, and for y-axis you just want to go with trips distance. So for example, if you want to visualize data, you can just click in here and drop it in here. As you have a dataset as trips, so you can just click in here. You can select the chart that you want to show in here. For example, you can go with scatter, and you have to select x-axis and y-axis. You can just click in here, and for example, you just want to go with fair amount, and for y-axis you just want to go with drop off zip or pick up zip or trip distance as well. So here you can see you have the visualization of scatter chart as per these values. You can change the color, size, or tooltip as well, and add annotation as well if you want to. So this is how you can use sample data in Databricks. You can use the code as well. For that, you can just go back to Workspace and go to your notebook and type in here as df equals spark dot read dot table, and you will have to write as samples dot nyc taxi dot trips. And after that you will just have to write in here as display and df, and you have to run this command in here. It is fetching results. So this is the data that you used in visualization, and you can use this code to display all this data in here, and you can review it and change that as well if you want to. Here df, that specific keyword, stands for data frame. It's just a table of data stored in memory. Option 2, uploading your own dataset. Let's say you want to upload a dataset, maybe a CSV file you downloaded from Kaggle or created in Excel. Here's how you can do that. You can just click in here as upload file, and you can just click in here to browse one. And here's the file you downloaded, and you can just click in here, click on open. And here you can just click in here to create table. It is being created. Now if you want to visualize data, you can just click in here and you can just drag it in here, and the data has already been uploaded, so you can just click in here. And if you want to go with, for example, heat map, and click in here as, for example, you can go with series title 1, and for y-axis you can just go with group, for example. And here you can see you have a data that is showing series title 1 and group as well. So you can change this as well by clicking here and add y-axis as, for example, magnitude or period or anything you want to go with, for example, series reference. So this is the heat map. To view in your notebook, you can just go in here as workspace and go to your notebook, and here you will just have to scroll down a bit and add a new code cell, and you can just type in here as df, which is a keyword, and equal to, and spark dot read dot csv. And here you will have to write a path. For example, you can just click in here as file store and tables, and name of the table, for example, you have in here. And now you will have to write a csv file name, so we'll just go back in here and click on downloads as copy this one and go back in here, paste in here, and after that you will have to write comma in here, and header is equal to true, and info schema true, and display df as well. So you can just click in here to run this one. So basically this is a syntax that you can use to open a file in here. In this code, header is equal to true tells Databricks to use the first row as column names, and info schema true attempts to automatically detect numbers, dates, and text. Best practice: always display the dataset immediately after loading to ensure it appears correctly. Checking your import. Once you have loaded a dataset, here's a few things to check. Does it have a column headers? If not, the first row may have been misread. Do the values look correct? No blank rows or weird characters? How many rows and columns are there? These checks will help you avoid analyzing broken or incomplete data. Real world example. At Airbnb, data scientists import nightly booking data from cities worldwide. They often use .csv or .parquet formats, depending on the size and structure. The key part: they always check for duplicates, missing columns, or errors immediately after import, because a single broken row can skew price predictions or availability models. Even in your class project or assignment, treating your dataset with care helps you think like a professional. Importing a dataset might seem like a small step, but it's a powerful one. Once your data is inside Databricks, you can start exploring, analyzing, and even visualizing it. Today you opened the door. In the next lecture, we'll start walking through that door by learning and summarizing your data, so you can start turning raw numbers into insight. Basic data exploration commands. Let me ask you this. If someone handed you a 10,000 row spreadsheet, what's the first thing you would do? Probably scroll, skim the columns, or check if anything looks strange, right? In data science, we perform the same task, but with a few simple commands that enable us to explore quickly and clearly. Why explore first? Exploration helps answer important questions. For example, what kind of data do I have? Are there any missing values? What's the range of values? Are there any weird outliers or patterns? Just as reading a book summary before dividing into all the chapters, basic data exploration provides a big picture of your dataset. Step 1. View the first few rows. Use the display command to preview a table in Databricks. For example, you just go to Notebook and you just write a command in here as df is equal to spark.read.table and this one as samples.nyctaxi.trips. So this is basically the command to call this table of trips. And now you use display function to view the table. For example, you just write display df and press enter and click on run. So this is a table. This is often the first thing you do after importing data. It shows a scrollable table view of your dataset. So for example, you can scroll down. Yes, it has around 10,000 rows. To view just the first 5 rows in raw format, you can just click in here as code and you can just write in here as df and dot show and 5 and run this command. So here you can see it has first few rows from this as fair amount, pickup zip and drop off zip as well. Step 2. Check the schema. The schema provides the column names and data types for each one. For example, string, integer or double. To check one, you can just click in here as code cell and type in here as df.print schema. And just run this command. So here you can see pickup date time is timestamp, drop off date time has timestamp as well, and distance has double, fair amount is double, pickup zip is integer and drop off zip is also integer. This is useful when you're working with unfamiliar data. You can quickly determine whether a column contains text, numbers or dates and identify any anomalies. Real example. At companies like Spotify, data engineers routinely check the schema of their streaming logs to ensure time formats and user IDs are being captured correctly. Even a small mismatch, like a column mistakenly set as a string instead of a timestamp, can affect downstream metrics. Step 3. Count rows and columns. To get the number of rows, you can just add new code cell and type in here as df.count and this one and run this code. Here you can see it gives 21,932. To get the number of columns, you just write in here as new code cell and type in here as len and df.columns and run this command. Here you can see it shows as 6 columns. When you scroll up, here you can see 1, 2, 3, 4, 5 and 6. So we have 6 columns in this dataset. This indicates the size of the dataset and the amount of data you will be working with. Step 4. Get a summary of the data. Want to know the average, minimum and maximum values in numeric columns? And you can just type in here as df.describe and .show and run this command. This provides quick statistics including count, mean, standard deviation, minimum and maximum. You can also learn a single column stats like this. You can just add a new code cell and type in here as df.select and for example you just want to go with trip distance and .describe and .show and just run this command. So here you can see you have all this summary for this specific column as count, mean, standard deviation, minimum and maximum as well. Use this when you're trying to understand patterns or compare features. Step 5. Find distinct values and frequencies. If you're curious how many categories are in a column, you can just type in here as add a code cell first of all and type in here as df.select, and for example you just want to go with fair amount, and dot distinct and dot show function, and just run this command. And here you can see you have all this result as only showing top 20 rows. Or to count how often each value appears, you can just write in here as create another code cell and type in here as df.group by, and for example fair amount, and you can go with for example dot count and dot show, and run this command. And here you can see you have all these results and it is only showing top 20 rows. This is especially helpful when working with server results, transaction types or product categories. Real example. At Walmart, analysts group transactions by store or payment type to spot buying patterns and regional preferences. These quick counts help identify trends before diving deeper. Analyzing data is not the flashiest part of working with it, but it's one of the most important. It's like meeting someone for the first time. Before you trust what they say, you want to know a bit about them. The same goes for datasets. With just a few simple commands, you have learned how to peek inside, check the structure, and get a feel for what's going on. These skills are utilized daily by data professionals across various industries, including marketing and public health. What makes data messy? Have you ever tried to fill out a form online and entered your phone number one way, only to see the site reject it because that's not the right format? That's a small example of what messy data looks like. And in large datasets, it can show up everywhere. What do we mean by messy? Messy data is not about how the file looks. It's about how reliable, complete, and consistent the information inside is. Messy data has missing values, uses inconsistent formats, dates, numbers, or names, contains duplicates, includes typos or wrong entries, lacks structure or clear labels. Let's break this down with real examples. Missing data. This is the most common problem. Sometimes cells are just blank. Example. A dataset of customer orders might be missing values in the email or shipping address columns. If you're trying to send follow-up messages or analyze shipping delays, those blanks become a real issue. In Databricks, you can spot this by using, for example, you just type in here as df.filter, and you can just again df, and for example you just want to go with different columns like we have in here. For example, you just want to go with fair amount, so you will just write in here as fair amount, and again you will just write in here as is null function, and close this one, and to show function. So you will run this command, for example clicking here. So this shows that in this specific table there is no blank cell in this specific fair amount column. Case insight. A healthcare startup once analyzed patient data to build a treatment model, but forgot to remove patients with missing diagnosis dates. The model produced wildly inaccurate predictions because it was trained on incomplete records. Inconsistent formatting. Data that appears correct but is written in different formats can cause silent errors. For example, CA, California, and Calif, all referring to the same state. And dates written as date, month, year, year, month, date, and month, date, year. If the formatting is not standardized, grouping or filtering by values will give confusing results. Check with this. You can just add another code cell and type in here as df.select, and for example you just want to check the trip distance, or this one as dbep, and for example date time as pickup, and you just want to add a distinct and dot distinct function and to show function, and run this command. So here you can see duplicates. Duplicate records often sneak in through system errors or manual uploads. Example: two entries with the same customer ID, order ID, and timestamp. If not removed, duplicates inflate metrics such as total sales or the number of users. In Databricks, you can just click in here, add new code cell, and you can just type in here as df.groupby, and for example you just want to go with which column, as for example what could have a different one. So you can use pickup time, so you will just write in here as group by and ptp and pickup date time, and for example you just want to go with count function and filter. Before that you will just write in here as dot filter and count is greater than 1 and show function. So you will run this command. So these are the results, which means that each of this pickup time has two values and they are duplicates. Typos and mislabeling. Humans enter data. Mistakes happen. For example, NY instead of New York, and product 123 labeled as product 213. Even one letter off can break grouping or matching logic. This often requires manual review or the use of tools such as spell correction, regular expression, regex patterns, or fuzzy matching. Structural issues. Sometimes the dataset is just poorly organized. Column names are unclear. For example, var1 or x2. The data is split across multiple unrelated files. Headers are repeated in the middle of the table due to formatting errors during export. You will spot this visually when you display df or see strange outputs from df.printSchema function. Why it matters? If you jump straight into analysis with messy data, you risk drawing wrong conclusions, making inaccurate forecasts, losing trust in your work. In professional settings at companies like Facebook, IBM, or Netflix, data cleaning is considered the most time-consuming part of any project. Analysts often spend 60 to 80% of their time cleaning and preparing data before they even begin modeling or reporting. You don't need to clean perfectly today, but you do need to develop a sharp eye for what's wrong, and that starts with asking, does this look trustworthy? Today's takeaway is simple but powerful. Messy data is the rule, not the exception. Your job as a data professional is not just to run commands. It's to ask, can you trust this data? And know what to look for before you dive into deeper analysis. What is data cleaning? Have you ever tried calculating an average and received a strange result, such as NaN, not a number, or a number that is significantly off from what you expected? Chances are the problem wasn't your math, it was the data. What is data cleaning? Data cleaning is the process of correcting, fixing, or removing errors, inconsistencies, or gaps in your datasets so that it's accurate and ready for analysis. It doesn't mean changing the meaning of the data. It means making it trustworthy. A clean dataset has consistent formatting, dates, names, and categories. Has missing values either filled in or removed. Has duplicates removed. has column names that make sense, is free from typos, noise, or errors. Think of it like proofreading a paper. You're not changing the core message, you're just ensuring it's readable, logical, and error free. Why is it so important? Imagine you're analyzing sales data for a retail chain. If some prices are listed as $20 with dollar sign, others as 20 USD, and a few as just 20, your analysis will break. Averages won't calculate correctly, filters won't work, and your insights completely unreliable. Real case insight. A 2016 report from IBM estimated that bad data costs the US economy $3.1 trillion a year. From marketing errors to flawed business decisions, dirty data has real consequences. Common cleaning tasks with code examples. Let's walk through the types of tasks you will often perform during cleaning and how to approach them in Databricks. Removing duplicates. For that, you will just write in here as df underscore clean and equal to df dot drop duplicates. And this function, and when you just run this program, here you can see when you just click in here, it shows that the duplicates value has been dropped. Why it matters? Duplicates can inflate counts and lead to misleading results. For example, two identical customer entries could double your sales figures. Handling missing values. To remove rows with missing values, you can just write in here as add another code cell and just type in here as df underscore clean equal to df dot drop na and function, and when you just run this code, and here you can see this line of code has been implemented on all these columns. To fill missing values, you can just write in here as first of all add code cell and start typing as df underscore clean and equal to df dot fill na and this one and braces. For example, you have in single quotes fair amount and default value is 0.0, and just close this one and it should be in single quotes as well. Now when you run this program, it has been implemented on all these columns as well. Why it matters? Missing values can cause functions to fail or distort summary stats. Standardizing formats. Say you have inconsistent figures in a column like fair amount, for example, and to standardize that, you can just click in here, add another code cell and just start typing as df underscore clean equal to df with column. So you will just write in here as fair amount and click on tab, and it means here you can see. So this line of code means every time you will enter a fair amount, it will be in double. So when you just run this line of code, so it has been correctly implemented, and here you can see as the fair amount will have a double in here. You can also standardize date formats or trim extra spaces. Why it matters? Inconsistent formatting makes it difficult to group, filter, and merge datasets. Renaming columns for clarity. To rename your column, you can just click in here as new code cell and just type in here as df underscore clean is equal to df dot with column renamed, and you can choose this one. And now you will just type the name of the column that you want to change, like for example tpet pickup date time to pickup date time, and you can just click on tab. And now when you just run this line of code, you can click in here, and now you have pickup date time as timestamp. So the name tpet pickup date time has been changed to pickup date time. Why it matters? Columns like x1 or var2 are not helpful. Clear names reduce confusion and improve collaboration. Filtering out invalid entries. Example: removing rows where age is negative or unreasonably high. For that, you will just type in here as df underscore clean equals df.filter, and for now you will just type df and the column name, for example pickup date time, and is not null, so it should not be null. So when you just run this line of code by clicking in here, and here you can see now this column will never be null, and now this program will give an error if this specific column will be submitted with a blank cell. Why it matters? Outliers may be due to data entry errors. At scale, they distort trends and graphs. Cleaning is iterative. You don't clean once and move on. You clean, inspect, and repeat the process as needed. Sometimes you will catch issues late in the process, and that's okay. Experienced data professionals don't rush. They stay skeptical and ask, does this value make sense? Are these columns formatted consistently? Am I missing anything strange? Mindset shift from coding to questioning. Data cleaning is not just a technical task, it's a critical thinking exercise. You're constantly balancing what is technically wrong. What could go wrong later if I leave this as it is? That's why companies like LinkedIn, Uber, and Airbnb employ full-time data engineers and analysts, whose primary job is ensuring data quality, not analysis or modeling, but rather making sure the data can be trusted. Data cleaning might sound tedious, but it's where real skills and judgment come into play. It's the part of the process that separates casual users from thoughtful analysts. The truth is, any insight or graph built on flawed data is flawed from the outset. However, once you know how to identify and resolve issues, you are one step closer to producing meaningful and accurate work. Handling missing values and typos. Have you ever taken a survey and skipped a question or misspelled something in a hurry? Now imagine thousands of people doing that and their answers ending up in a dataset you are trying to analyze. That's the kind of issue we're talking about today. Part 1. Handling missing values. What are missing values? Missing values are empty cells in your dataset. They can appear for many reasons. A person skipped a question on a form. A sensor failed to record a measurement. A value was either deleted or omitted during data entry. In Databricks, missing values show up as null. Why they matter? If you try to calculate an average, group by a column, or build a model, missing values can cause errors, produce incorrect results, bias your conclusions if left untreated. Real case insight. In 2021, a retail company misjudged inventory levels because 12% of entries for in-stock units were blank. The analysis assumed zero, resulting in underordering during the peak season. How to detect missing values? You can filter them like this. First of all, we'll implement this in on another table, and we'll just type in here as, if we just want to display that, so we'll just type in here as display function and df. So when we'll just run this line of code, you can just click in here. So we have all these columns, and for example, if we just want to go with customer ID to check if it has a missing value or not, so we'll just scroll down a bit and type in here, add another code cell, and type in here as df.filter, and for example df and bracket, for example customer ID. So we'll just write in here as customer ID, and to check whether it is written just like that, so we'll just go up, and C is in small, so we'll just write in here as C customer ID, and we'll just check whether it is null or not. So for that, we'll just write in here as dot is null, and we just want to show them, so we'll just write in here as show function. We'll just run this command, click in here. So here you can see it shows no record. It means that no column for customer ID has blank space. or check for them in all columns. You will just write another code cell and just start typing here as df.select, and for example this one, and col as c is null. So to check if it is null or not, so is null function, alias c for c in df.columns. So we'll just click on tab as we have to write this code, so you can click on here. As we just have to write this code, so you can just press tab and this code will be implemented. And we just want to show that, so you can just click in here and show function. But before running this code, we have to import this one as col, so you will just go up and first of all just select and just type in here as from PySpark function import as col. So now when you just run this line of code, you can just click in here. So it means that there is no column in here that has a blank space. So false means that there is no entry in here which has a blank space. Fixing missing values. Option 1, drop rows with missing values. For that, you will just click in here to add another code cell and type a code in here as df_clean equals and df dot drop na function and run this line of code. It means that every row which has a blank column or a blank space, then that column will be deleted. Option 2, fill missing values with a default. For that, you can just write another code in here and start typing in here as df_clean and df dot fill na, and for example you can just click in here, and for example you just want to go with, if you don't know the value of, for example, phone number or customer ID, you can just click in here as customer ID. And now here you can see it just gives a suggestion that if we don't enter a customer ID, the default value is 0, first name will be unknown if we don't know. So it means that if we don't have the exact information of a customer, instead of leaving it a blank, we should give it a default value, for example unknown, 0 or anything else. So you can just click on tab and here you can see, and you can just press on tab again. So here you can see, instead of leaving it blank, you can have this default values and you can change that as well. So when you just run this line of code, so it has been implemented. So every time you leave a blank cell, then these default values will be entered automatically. This is helpful when you want to preserve the dataset size. Option 3, use statistical values. Example, fill missing fair amount values with the median fair amount. To implement that, we'll just add code cell in here, and if for example if you're working on this table, and you can just scroll down and just start typing in here as median underscore fair amount, and you can just go with equal to. So as we have to implement this specific command as approx quantile, so you can just click in here and you can just press tab and you can just go with df dot fill na and function will be. So as we have to implement this specific code, so you can just press on tab. So here you can see we have just set it to 0.5 and 0.25, so it means that 0.25 will be implemented as 0.5 to approximately quantile that. Part 2. Handling typos. What are typos in data? Typos happen when text is entered manually. They can create multiple, slightly different versions of the same value. Examples: California versus Calif versus California, or Visa versus Visa versus Visa. When you attempt to group or filter data, these inconsistencies result in messy outcomes. Detecting typos. Look for unexpected or rare values. For that, you can just click in here as code cell and type in here as df.groupby. And for example, you just want to check that gender and dot count and dot show function. And when you just run this line of code, here you can see male have been mentioned 149 times and female has been mentioned 151 times. If you see one version used 10,000 times and another used once, it might be a typo. Option 1. Standardize casing and spacing. For that, you can just click in here as new code cell and type in here as from PySpark.sql.function, and you just want to import trim and lower. And now, for example, you can just want to go with df_clean and you can just press tab. And for example, if we just want to go with one of the columns, so you can just remove others as first name and trim and lower as first name, and just close this one and this one. So when you just run this program in here, this turns every first name to lowercase alphabets. Option 2. Replace known typos manually. For that, you will just type in here as df_clean and you can just go with df.replace. And for example, you just want to replace ny in the state ny to New York. So you will just type in here as ny to and New York. It is useful for small, no inconsistencies. Option 3. Advanced. Use fuzzy matching. Outside this course scope, but commonly used with larger or messier datasets. Real case insight. A telecom company found over 300 different entries for United Kingdom in their customer database, from UK to the United Kingdom of Great Britain. After cleaning, they reduced their country column to just 21 standard entries, improving their segmentation model accuracy by over 20%. Missing values and typos are minor issues that can cause significant problems if left unaddressed. But once you learn to spot and fix them, you move closer to clean, trustworthy data that can actually lead to meaningful insight. Creating simple charts and graphs. Here's a quick question. If you had to explain 10,000 rows of data to someone in 30 seconds, how would you do it? Why visuals matter? Data on its own can be overwhelming. Charts make it digestible. Example. Imagine a table showing daily sales across 300 stores. Instead of reading all those numbers, a line chart can instantly show whether sales are rising or falling. A bar chart can highlight which regions perform better. Professionals at Amazon UNICEF and Spotify use visuals every day to communicate everything from customer trends to social impact. Types of basic visuals in Databricks. Databricks makes charting simple through the display function. Once a data frame is displayed, you can switch to different chart types using the visual editor above the table. Let's walk through three common ones. Bar charts. Best for comparing categories. For example, total sales by store or number of rides by day of week. To visualize the data in bar charts, you can just click in here as dashboards, create a new dashboard in here and click on data. If you have a data, then you can just upload in one, but if you want to go with sample data, you can just click in here, click on all and click on samples, and you can use any of these databases. For example, we just want to go with bakehouse, and here you have multiple tables and you can choose any of these. For example, you just want to go with sales franchises, so you can just click in here and click on confirm. So here you can see you have just uploaded this file, and now you will just press in here as plus icon and click in here, add visualization. For example, you just want to put a bar chart in here, you can just click in here, and now here you can see you have just already uploaded the sales franchise as it shows, and you can just click in here as bar chart. So if you want to highlight a bar chart, you can just click in here, and now you will have to select x-axis and y-axis values. So for x-axis you can just click in here, and for example you just want to go with supplier ID, and for y-axis you just choose for example name and click in here, and here you can see you have this bar chart in here. And if you want to change the x-axis, you can just close this one and click in here again. And for example, if you want to go with country, so you can just click in here. Here you can see this graph shows that these companies have branches in these countries in here. Line graphs, best for tracking changes over time. For example, daily sales, temperature, or website traffic. For that, you can just click in here, visualization, and just put it in here. And now, for example, if you want to go with line chart, you can just choose any of these. For example, this one or this one as well. So for x-axis, you can choose any of these. For example, you just want to go with franchise ID, and for y-axis, you choose name or size or zip code. So you can choose any of these, but for example, you just want to go with country, so select in here. So here you can see you have this specific graph in here. Or if you want to change y-axis, you can just close this one and select any of the other, for example size. And for x-axis, you can just close this one and choose another one in here as for example name. So you have this graph in here. Line graphs help reveal trends such as slowdowns or spikes that a table can't. Pie charts, best for showing proportions. For example, percentage of users by country or category. For that, you can just click in here as visualization. You can just click in here, and for example, you just want to put it in here and select pie chart from there, and here is the pie chart. And for angles, you can just click in here and you can choose one of these. So for example, you just want to go with district or country or city as well. So if you want to go with country, so click in here. So for x-axis, we will choose franchise ID, and for y-axis, we'll choose a city, for example. And from visualization, you will just have to click in here and choose a pie chart. And here you can see this is the output. Pie charts work best with fewer than 6 to 7 categories. Other visual features to know: filter inside the chart editor, focus on specific value, hover to see exact values, great for presentations, change colors and labels to enhance readability. For that, you can just click in here and scroll down a bit, and here you can see you can change the color of every city. And when you just click in here, and you can use custom as well. So for example, you just want to go with a little lighter and click in here. So here you can see it has been changed. Real world example: Airbnb. Airbnb uses visualizations daily to detect patterns in booking behavior. by creating simple bar charts that show bookings by day of week and location. They have optimized check-in times and promotional offers in major cities. These decisions start with basic visuals, not complex models. Best practices. Always label your access clearly. Don't overload charts with too many categories or lines. Use visuals to support a question. What are you trying to understand or explain? Good visuals tell the truth. Great visuals tell a story. Creating chart is not just about making your data look good. It's about making it understandable. With a few simple clicks, you can turn raw numbers into a clear visual story. And when that story is clear, it has the power to inform, to persuade, and to guide better decisions. Plan your first data project. Have you ever started a group assignment and halfway through thought, wait, what are we even trying to answer? What is a data project? A data project is a process where you ask a question, use data to explore that question, clean and organize the data, run simple analysis or visuals, share your results and insights. It's not about finding a perfect answer, it's about showing your process and making sense of what the data reveals. Real example. At National Geographic, data analysts use basic data projects to explore animal migration patterns. They don't model everything at once. They start with questions like, how does movement vary by season? Or, do younger animals travel differently? From there, they build. That's exactly the approach you will take. Step 1. Define your question. Start with something specific and realistic. You're not trying to solve the climate change. Instead, try, what are the most common payment methods for New York City taxis? How do trip distances vary by time of day? Which store had the highest sales last month? The best questions are based on a single dataset, focused on one or two variables, easy to support with charts or basic summaries. Step 2. Choose your dataset. Pick one dataset you have already used a sample of or uploaded. Ask, do I understand the structure? Is the data clean enough to work with? Do I know what each column means? Don't choose a dataset with dozens of columns you don't understand. Simpler is better. Step 3. Outline your steps. Think of this like a checklist. Preview the data. Display function. Check for missing values. Filter function. Clean if needed. Remove duplicates. Fix typos. And fill in blanks. Group or filter data. Ask your questions using code. Visualize your result. Bar chart, pie chart, or line graph. Add text summaries. Explain what your chart or count means. You don't need to do complex math. You just need to be thoughtful. Step 4. Make it readable. Use markdown cells in your notebook to introduce your question. Describe what each block of code does. Write a conclusion about what you found. This is what makes your notebook a project, rather than just a list of commands. Pretend someone else has to understand your work. Would your notebook make sense to them? Step 5. Know what success looks like. Your first project doesn't need to be a deep. A great project simply answers a clear question, uses 3 to 4 well-labeled code blocks, includes a chart or visual, ends with a short summary of what was found. If you can do that, you're doing what real analysts do in day-to-day work. Example scenario. Project title. Which days have the most taxi rides in New York City? Dataset. Samples.NewYorkCityTaxi.trips. Steps. Create a column for the day of the week. Group by that column. Count rides and create a bar chart. Summarize your findings. Result. Friday and Saturday have the most trips. Weekends see more activity, likely due to nightlife and tourism. That's it. Clean, useful, and realistic. Planning your first project is like sketching before painting. It gives you structure, direction, and clarity. And in data work, that structure is everything. It helps you stay focused and produce something that's not just technically correct, but actually useful. Sharing and exporting your notebook. Have you ever done all the work only to realize you don't know how to show it to anyone? That's what we are solving today. Why sharing and exporting matter. In real-world data roles, the value of your work is measured by how well others can understand and use it. Whether you're working on a team or submitting a portfolio project, how you present your notebook affects how it's received. A notebook that is clean, annotated, and easy to open is more impactful than one filled with raw code and no explanation. Sharing your notebook in Databricks. Databricks enables easy collaboration by allowing you to share notebooks with others in your workspace. Steps to share. First of all, we'll just go to Workspace and click on a notebook that we have been working on. So this is the notebook we have been working on in this course. Click the share button on the top right of your notebook. Here you can see when you just click in here. Here you will have to enter their email address or username. And from here, you can choose their permission level. For example, when you just click in here, you have options like can manage. It means that it will have the same privilege as the admin. Can edit. Full editing access. Can run. They can run code but not edit. Can view. They can read only. Add a message to clarify what you're asking them to review or do. Use case. You're working on a team project. You give your teammate can edit access so they can build charts while you can clean the data. Exporting your notebook. When you need to share your work outside Databricks, exporting is key. Export options. HTML for visually polished sharing, ideal for portfolios or reports. PDF, good for emailing or printing your work. Source file, for sharing raw code with another notebook tool. How to export. Click the file icon on the top left of the notebook. Here you can see, you can just click in here and select export option, as you have 4 options in here as DBC archive, source file, IPython notebook and HTML. You can select any of these. For example, you just want to go with HTML, so click in here. And here you can save it. For example, you just rename it as New York City taxi trips. And you just click on save. And here you can see it has been saved in HTML format. Best practices before sharing or exporting. Clear the output. Use clear state and outputs to remove bulky visuals or intermediate visuals. Organize your cells. Title sections with markdown headers. For example, data cleaning, analysis, etc. Use consistent formatting and remove unused code cells. Use markdown text cells effectively. Write short explanations before and after each major code block. Summarize at the end. Add a conclusion section. For example, here's what we found and why it matters. Real-world example. In a university capstone project, one student exported their Databricks notebook as a PDF and submitted it with a job application. Because it was clean, visual, and had explanations, the hiring manager could follow their logic without needing to run the code. They later got an interview because the notebook made a strong impression. Sharing your work is not just the final step. It's what turns your work into something useful and professional. Whether you're collaborating on a team or showcasing a project to get hired, how you package your notebook matters just as much as what's inside it.